How do access point frequency bands work? Have you ever wondered how your devices connect to the internet wirelessly? One of the key players in this process is the access point. Today, we will look at how access point frequency bands work and what they mean for your network experience. Access points use specific frequency bands to send and receive wireless signals. These bands are ranges of radio wave frequencies that are dedicated to Wi-Fi communication. The frequency bands you often hear about are 2.4 GHz, 5 GHz, and the newer 6 GHz band. Each band has its own unique characteristics that affect speed, range, and interference. Let's start with the 2.4 GHz band. This band is the oldest and most widely used for Wi-Fi. It has a longer range and can penetrate walls and obstacles better than the other bands. However, it supports lower maximum data speeds, typically up to about 100 megabits per second. Because many devices, like microwaves and Bluetooth devices, also use this band, it can face interference. Additionally, there are fewer non-overlapping channels available, usually just 3, which can lead to congestion in busy areas. Next, we have the 5 GHz band. This band offers higher data rates, reaching up to around 1 gigabit per second. It supports wider channels and experiences less interference from other devices. However, its higher frequency means it has a shorter range and does not penetrate walls as well as the 2.4 GHz band. On the bright side, it has more non-overlapping channels, around 24, which helps reduce interference and improves performance in crowded environments. Now, let's talk about the 6 GHz band. This band is the newest addition to the Wi-Fi family and supports the highest speeds, potentially exceeding 2 gigabits per second. It also offers many more channels, which greatly reduces congestion and interference. However, it has the shortest range and weakest penetration of the 3 bands, making it ideal for open spaces or close-range connections with modern devices. Access points can operate on a single frequency or support multiple bands. Many of the latest access points, especially those using the Wi-Fi 6E standard, can work on all 3 bands. This allows them to optimize connections by choosing the best band based on the device and network conditions. From a physical network infrastructure perspective, the choice of frequency bands impacts bandwidth availability, latency, and overall network performance. In environments like data centers or offices, using dual or tri-band access points helps distribute devices across bands. This reduces interference and improves overall throughput, which is essential for efficient network routing and bandwidth management. To sum it up, access point frequency bands provide different ranges of radio frequencies that balance coverage, speed, and interference. Understanding how these bands work can help you design a wireless network that meets your specific needs for speed and range.